All right, in this lesson, we're going to be looking at parallel circuits. Now, we're going to keep them fairly simple where we just have one resistor on each branch, so we can do simple calculations. The thing about parallel circuits, there's more than one path for the electrons to flow. So our amps will be divided up over each of those branches in a parallel circuit. The voltage is going to stay the same across each of those branches. Okay, so the current gets divided up, but the voltage, or you can kind of think of that as the pressure, stays the same. Now, the higher the resistance, the lower the current flow. So if you've got a really large resistor with a lot of resistance, then you're going to have fewer amps going through that branch than a branch that has fewer ohms of resistance. All right, so now we have a formula for finding the total resistance. It's 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Okay, and I've had students who said, oh, well, since all of those are in the denominator, can't we just add those up? No, we cannot just add R1 plus R2 plus R3 to get our total. Now, we can do that with a series circuit, but with this one, remember, when we're adding fractions, our denominators would have to be the same. But what we can do is set these up. Now, if you're using a scientific or graphing calculator and you know how to use it, you can just do 1 divided by 800 plus 1 divided by 1,000 plus 1 divided by 1,200 and get your answer. Your calculator will do order of operations, so it'll do division first. Then you can actually raise that to the power of -1, which takes the inverse of that answer to get your final answer. But if you're using a simple calculator or you're not sure how to do the -1 exponent, I can just change each of those to decimals. Just 1 divided by 800 is 0.00125. 1 divided by 1,000 is 0.001. Then 1 divided by 1,200 is 0.000833. And the 3 is repeating, so I just rounded that one off. All right, when we add those together, we get 0.003083. Now we're going to take 1 divided by that number. Put 1 over the number, or 1 divided by that. And we get 324.36 ohms, rounded off to the nearest hundredth. Okay, so I've got my total resistance of 324.36 ohms, and I've got 20 volts. Now, one thing about our total resistance with parallel circuits, our total resistance is going to be lower than our smallest resistor. So in this one, I know that if I get resistance higher than 800 ohms, then I know I've done something wrong. It's going to have to be less than 800 ohms. And the more branches we have, the lower it's going to be because it's got more places divided up. All right, but now I can find my current. I can find out how many amps are flowing in this circuit. I cover up the I. So it's E divided by R. So we've got 20 divided by 324.36, which comes out to 0.062 amps, or you could say 62 milliamps. I can also figure out how much current is going through each of those branches. Okay, for that first branch, I just take the 20 divided by 800, and I get 0.025 amps. I can take the second one, 20 divided by 1,000, and I get 0.02 amps. For the third one, 20 divided by 1,200 is 0.017 amps. Like I was saying before, the smaller the resistor, the more current we'll have flowing through it. So our lowest resistance is 800 ohms, and we have more amps going through that one than the other two. We've got 0.025. The 1,200 ohm resistor, we have the fewest amps going through that one, 0.017. Now, if we add those three up, it should equal our total resistance, which it does. 0.025 plus 0.02 plus 0.017 does equal 0.062. If those numbers are different, then we've made a mistake somewhere, or we could have a rounding issue if we round off our numbers too much. All right, let's look at an example with two resistors. Here we're going to use 20 volts, a 50 ohm resistor, and a 100 ohm resistor. All right, so let's start out by calculating our total resistance. So I've got 1 over RT equals 1 over 50 plus 1 over 100. When I do the division, I get 0.02 and 0.01. If I add those together, I get 0.03. So my total resistance will be 1 divided by 0.03, which is 33.3 repeating. And so I'm just going to round that off to 33.3 ohms. So that's my total resistance. Now I can find the resistance for each branch. And we're doing this, it's like just calculating a simple series circuit with one resistor. Okay, so with that first branch, I just take my 20 divided by 50, my E over R, and I get 0.4 amps. Then for the R2, 20 divided by 100 is 0.2 amps. If I add those together, my total resistance is 0.6 amps. Now I can check that by taking my voltage divided by my total resistance, 20 divided by 33.3, and it comes out to 0.6 amps. So both of those are the same. So I can be pretty confident about my calculations. All right, let's look at one more example. This one with 3 resistors. So we've got a 500 ohm resistor, a 100 ohm resistor, and another 100 ohm resistor. First, I'll calculate my total resistance. Again, I just substitute my resistance in each of the fractions. So we've got 1 over 500 plus 1 over 100 plus 1 over 100. I want to change those to decimals. So I've got 0.002, 0.01 plus 0.01, which comes out to 0.022. Then we take 1 divided by 0.022, and I get 45.45 repeating. So I'm rounding that off to 45.45. And that's my total resistance. All right, so I'm going to bring that down there. All right, I can get my total current, take my voltage, divided by the 45.45, and I get 0.198 amps. Now let's calculate each of the branches. So going through that first resistor, 9 divided by 500 is 0.018 amps. Going through the second resistor, 9 divided by 100 is 0.09. The third resistor is the same as the second, 9 divided by 100, 0.09. If I add those three up, my total current comes out to 0.198 amps, which is what we calculated when we used our total resistance. Okay, so that's how we can calculate our total resistance and our current for each branch when we're looking at just one resistor on each branch. Now, eventually we'll get to more complicated ones, but we're going to keep it simple for right now with just one resistor on each of the branches.